So one thing that we need to do is to be able to use numbers, and to use numbers in physics to predict things. We want to compare things, we want to predict things. So we need to use numbers, and for that we need to understand significant figures, scientific notation, and units. What is a measurement? Well, a measurement is basically you compare the one property of an object with a scale that you have. For instance, here we are measuring the diameter of this tool. So when we measure the diameter of this tool, we have to give that measurement with certain precision. We have to say, well, this is how good my measurement is. In this case, well, we are measuring the diameter here, and it comes out to be 15.57 millimeters. That means we have 4 digits. Those are your significant figures, and your precision is 0.01 millimeters. That's how good this measurement is. So the number of digits that you need to reliably say this is what the measurement is called significant figures. When you have significant figures, then when you have measurements in physics, you may need to multiply them, to add them, to divide them. You need to do algebraic operations in them. And when you do that, the question is, how many of those significant figures do you keep? Well, it is basically common sense. And what we need to realize is that if you have 2 measurements and you multiply them, for instance, you cannot obtain something that is more precise than what you had. For instance, here I have a measurement with 3 significant figures, and here I have a measurement with 2 significant figures. When I multiply this, the result cannot have 6 or 7 significant figures. In fact, it has to have, the reasonable thing is to say, well, my worst measurement is this. It has 2 significant figures. That is as good as this. This is as good as this is going to be. You're not going to have more than 2 significant figures because that's what you had here. So, and there is a similar rule for addition. So, but in general, the idea is that you can never have more significant figures than you started with. Another thing that we do in physics is that sometimes we need to work with very large numbers, or very small numbers for that matter. And then we need ways to write these numbers so it makes sense to us. And we use scientific notation for that. And basically, for instance, we have this number here, right? And this is a distance in meters, right? And this is the diameter of the Earth, right? So the number of significant figures is 3. These zeros actually contain no information. So I only have 3 significant figures, and I can write this in scientific notation as 6.37, 3 significant figures, times 10 to the 6. When I write this quantity that is here, right, this quantity in this format, I'm using scientific notation. I can do the same, for instance, for the average diameter of a red blood cell, which is which is this number here. That's very small and it has a lot of zeros. So the scientific notation way to write that is to write it as 7.5. I have 2 significant figures times 10 to the minus 6. How do I get this exponent? Well, the exponent in this case would be the number of times that I need to move the dot to get an expression with an expression with 1 digit dot something here. And the same in this case. So we have to move the dot. In this case, we move the dot in the other direction, and we get an expression like this. Units. In physics, we have to use units, and the typical units that we're going to use is for time, seconds. For length, we're going to use meters, but we could also use feet and inches, or miles, or kilometers. And for mass, we use the kilograms. If you use the seconds, meters, and kilograms, that is called the International System Unix, and that is commonly used everywhere. And if you use miles and feet and pounds and seconds, that is the system that we use here in the US. We will be using both interchangeably, so you should be familiar with both. And finally, one thing that we need to do a lot is unit conversions. And say for unit conversions is an operation that you need to be familiar with. Suppose a jogger, so you have somebody running, and the speed of that person is 6 miles per hour, right? 6 miles per hour, or we can write this in this mile per hours, but we're gonna keep the notation because it's going to be useful if we write like this, 6 miles per hour. And we would like to know what is that in meters per second, right? So how do we do that? Well, the idea is to basically, we need to change these to meters and these to seconds, and to do that we're going to take 6 miles per hour, and you're going to multiply that by 1, right? And 1 is what? Well, we have meters over here, so this is 1600 meters, and over here I have 1 mile, right? So by doing this, I'm going to be able to cancel the miles because I have miles upstairs here and downstairs here, and then I'm going to be left with meters. And then I need to convert this to seconds, and then I'm going to use the trick again and multiply by 1. But now I want seconds to be downstairs, so I'm going to have 600 seconds, and up I have 1 hour. So then this guy cancels this guy cancels this, and then I get that this is 6 times 1600 divided by 3600, and that is in meters per second, and that is equal to, these two cancel, and that is equal to, I'm going to use a calculator quickly here, that is 6 times 16 divided by 36, that is equal to 2.66 meters per second. That is the speed in meters per second of somebody running at 6 miles per hour. And that's how we do these conversions. Finally, we may need to estimate, and estimation is when you need to do a rough number, when you need to have a rough idea. You don't need to know the exact number. For instance, if I ask you, how long does it take to go from here to Pittsburgh? You can estimate that and say, well, if I drive at 60 miles per hour, it's roughly 60 miles, maybe an hour. That's an estimation. Sometimes we also need to do order of magnitude estimations. In that case, we need to have an idea of how big and how small something is. So estimations are is an important skill that we need to have. So okay, let's stop here, and I'm going to give you some problems for you to work on these later on in the week. Thank you.